Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will have a quick knowledge in topics of carbon capture utilization and storage, CCUS. And today's topic is about CO2 storage efficiency for aquifers. So we are going to focus on aquifer as a type of CO2 storage. Okay, so as usual in quick knowledge video, I take the message solely from the literature, actually from the paper. And if you're interested, I recommend these two papers. The first one is this one, Baku 2015. It's a review of CO2 storage efficiency in deep saline aquifers. It's a very important, it's very interesting paper. And then actually Baku uh, take a note from Goodman et al. Okay, so I go there also. And this is actually about US DOE methodology for the development of geologic storage potential for carbon dioxide at the national and regional scale. Okay, and US DOE is actually Department of Energy. All right, so here we have CO2 storage efficiency, okay, denoted as E at local and regional scale. Okay, again, it's about aquifer. So local scale aquifer and regional scale aquifer. So notice we have this table. The first column, we have types of lithology. So clastic aquifer, dolomitic aquifer, and aquifer from the limestone. Okay, and if you're asking, what is the typical storage efficiency coefficient for your current aquifer you're investigating? Okay, if it is clastic, then you can use these values. Here we have P10 for the pessimistic one, the low case, and P50 for the base case, and P90 for the optimistic case or the high case, both for local scale and aquifer or regional scale. Both of them actually for the aquifer, but the first one is for local scale and the second one is for the regional scale. So you can use this value, you can trust this value, but yeah, I don't know if you find latest or papers from later researchers, of course you can take that as well as a source of your information. Okay, but I think this is actually also a good data for the storage efficiency coefficient. All right, so let's check for the clastic local scale. P10 3.1, P50 9.1, and P90 it's quite high, 10%. And aquifer scale 1.2 for P10, 2.4 for P50, and only 4.1 for P90. Okay, for dolomite, okay, it is the greatest storage coefficient for the P10 and also for the P50. Okay, but for P90, it is a slightly lower than the clastic. All right, and again, for the aquifer scale, dolomite is the best. And also for the P50, dolomite also the best. But for P90, dolomite, okay, ranked as the second below clastic. Clastic 4.1% and dolomite 3.6. And limestone for P10, it's the second rank. It's still better than the clastic, but lower than the dolomite. But for the P50, the base case, actually, limestone has the lowest storage coefficient, storage efficiency coefficient, and also for the P90. Maybe you can guess, maybe there will be acidification reaction because we have CO2 dissolved into the water, creating acid, right? And then there will be reaction with the limestone. Maybe that's also a case that will lower down the storage efficiency, or maybe because of the highest or the high level of heterogeneity, perhaps. If you're interested, you can go to this Goodman et al. Paper. For the aquifer scale, it's slightly better than the clastic. For P10, it's again the third rank, the lowest one for P50 and also for the P90. So maybe the application coming from this is actually if you're investigating limestone aquifer, yeah, maybe you can take this as the risk. The storage efficiency coefficient is the lowest compared to clastic and dolomite. Okay, and along with the USDOA methodology, this data is used to produce the carbon sequestration atlas for the United States and Canada. Canada. Okay, so here you go. So if you're wondering what is the efficiency, the typical efficiency for aquifer, the typical CO2 storage efficiency of the aquifer, hmm, it's not it's not that high. Okay, the highest value here is only 10%. But don't worry, we have a large aquifer system in this earth. So even 10% of it will hopefully suffice to sequester CO2 coming from, coming from power plant, coming from cement industry, or coming from other sources. Okay, so 10% of the total storage capacity from all aquifer system that can be used for CO2 storage will also be enormous to sequester, to store, to contain CO2 that we are directing them into. Okay, so again, this is the data, and I think that's all. Thank you so much for watching. I hope you enjoyed this video. I hope this video is useful. Thank you so much, and see you again in the next quick knowledge for CCUS videos. Thank you.